So we continue with this next example. And one thing that I'd like to say is that one way to approach any of these problems is to think of them as puzzles or riddles that need to be solved. For me, that tends to put me in the right frame of mind as I investigate what needs to be done. So as we read this problem, it says, for her workout, Ennis jogs 2 miles to the beach every morning with her dog Hunter, maintaining a steady pace of 5 miles per hour. However, after the first mile, Hunter sprints off at a constant 8 miles per hour until he reaches the beach. At the same speed, he then immediately turns around and sprints back to Ennis. Once Hunter reaches Ennis, he turns and heads back to the beach again. Hunter continues this back and forth behavior at a constant 8 miles per hour until Ennis and Hunter reach the beach together. And the big question is, what overall distance does Hunter eventually run? So for the 4 steps, for Polya's 4 steps, this is where the first step really plays an important role. Make sure that we understand what the problem is saying. So as we go through this, it says for her workout, Ennis jogs 2 miles. So she's going to be jogging 2 miles, maintaining a steady pace of 5 miles per hour. So Ennis and Hunter take off jogging, and they're both trotting along at 5 miles per hour. After the first mile, Hunter then takes off running at 8 miles per hour until he gets to the beach, and then he turns around and comes and runs back to Ennis. Now, keep in mind that Ennis is constantly running towards the beach. So every time Hunter runs back and forth between the beach and Ennis, the distance gets smaller and smaller and smaller because Ennis is getting closer to the beach every time until eventually the two of them reach the beach together. And of course, that's the idea. We want to know how long does Hunter eventually run. Now, there is a relationship between the speed that you're running at, for how long you're running, and then, of course, how much distance you're going to cover. So, for example, if you're driving at 70 miles per hour, I'm just going to put it right here, and you drive for 3 hours, that means you would have covered 210 miles. 70 miles per hour for 3 hours, that's 210 miles. So there's a definitive relationship between the time and the speed and the distance. So now for step 2, we're going to devise a little plan here. And I'm going to draw a picture. A picture says 1,000 words. I think it says a lot, and it helps keep your thoughts in order. So I'm going to draw this distance here. So here's 0. Here's where Ennis and Hunter start, and here is the beach all the way down here, 2 miles away. And for the first mile, they run together at 5 miles per hour. So now that I have that, the next step is I'm going to devise some sort of plan to help me figure out the rest of what's going on. So that's step 3. So it's hard to tell exactly how far Hunter is going to be running because he keeps running back and forth, but as he comes back, he gets shorter and shorter and shorter every time to Ennis until they both reach the beach. However, I have 5 miles per hour here. So it would be nice to know how long it took them to reach 1 mile. Well, what this means is if they ran for 1 hour, and 1 hour is 60 minutes, if they ran for 60 minutes, after 60 minutes, they would have covered 5 miles. That's what 5 miles per hour stands for. Well, 1 mile is 1/5 of that distance. So that must mean they went 1/5 of 60 minutes. And 1/5 of 60 minutes, well, that's 60 divided by 5. That's 12 minutes. So it would have taken Ennis and Hunter 12 minutes to cover the first mile. Now, Ennis keeps going at the same pace of 5 miles per hour. So that must mean another 12 minutes. So after 24 minutes, that's when Ennis reaches the beach. And of course, that's the same time that Hunter does, but Hunter's doing this back and forth here. Well, when he's doing the back and forth, he's doing that at 8 miles per hour. So the only information I know is that he's going 8 miles per hour, and he's doing that for 12 minutes. So if he's going 8 miles per hour and he's doing it for 12 minutes, and 12 minutes is 1/5 of an hour, right? Then 8 times 1/5, that's 1.6. So Hunter actually covers 1.6 miles for the second 12 minutes. So here he does 1 mile, and here he does 1.6 miles. So Hunter covers a total of 2.6 miles. Ennis does 2 miles, Hunter does 2.6 because he's been going back and forth. Now step 4 says review what you did. And that's why I draw these pictures. It allows me to make sure that my drawings and my schematic here seems to make sense. 12 minutes here, it's still 12 minutes, but it's at a faster speed, so a longer distance is covered, so it seems to make sense. And I think we got it.